Hello and good afternoon, my dear kids. Welcome back once again to this short tutorial video for class 7 students. And since we were dealing with the sums regarding the triangles, and as I have already told you, during classification of the triangles, the one of the triangles is very important. You'll get entirely different topic for that triangle, isn't it? That triangle is a right angle triangle. So here too we will be dealing with a right angle triangle. Okay, it's just simple about right angle triangle. And the topic is your Pythagoras theorem. So, see, whenever you hear the term Pythagoras theorem, what should come in your mind is Pythagoras theorem, it only deals with the right angle triangle. Remember, among those 6 triangles, we have already done classification of triangles, isn't it? So, among those 6 triangles, whenever you hear the term Pythagoras theorem, or if you see a right angle triangle, simple. If you see right angle triangle and you are dealing with the sides of the right angle triangle, remember you are dealing with the sides, not the angles of a right angle triangle, Pythagoras theorem is applicable. Or whenever you see Pythagoras theorem in your question, just remember that time you will be dealing with a right angle triangle, that too with the sides of the right angle triangle. Okay, so since I have already given you this figure, I have given you before as well, so just for recall, I have drawn again the right angle triangle figure, and I have given you the sides again. Hypotenuse, this side is known as hypotenuse, the side opposite to 90 degree. Remember, the side opposite to 90 degree, where the angle 90 degrees from, the side opposite to it is known as hypotenuse, and this one is the longest side of the triangle, this triangle, right angle triangle. Okay, the hypotenuse is the longest side of this triangle. This line, this side is known as your perpendicular, height, or altitude as well. Okay, it has got 3 different names. It can be called perpendicular, it can be called height, or it can be called altitude. Okay, and this side can be called as base or adjacent. Okay, since all the terms are important, so I have given you all the terms, because sometimes they will be using adjacent and you might get confused, isn't it? So that is why I have given all the different names, okay, of the sides. And this side has only just one name, that is hypotenuse. That's it. Okay, and yeah, now whenever in a right angle triangle, when we are dealing with the sides of the right angle triangle, as I have already told you, that time the Pythagoras theorem, that is this theorem, is applicable. Now who was Pythagoras actually? Pythagoras, he was a mathematician. Okay, what he said was, in a right angle triangle, suppose if he was given a right angle triangle, he derived the theorem. Okay, he derived the formula, and that formula is actually known as Pythagoras theorem. So what he said was, suppose in a right angle triangle I am given with 2 sides, then I can calculate the third side. That's what he said. Okay, Pythagoras, he was actually a mathematician who said, suppose for a right angle triangle, if I am given with 2 sides of a right angle triangle, then he said I can easily calculate the third side. And how you can do that? He derived the formula, that is hypotenuse square equals to base square plus perpendicular square. Okay, now this one is a very important formula. Okay, very important formula, and this formula is actually known as your Pythagoras theorem or Pythagoras formula. Okay, Pythagoras theorem, and this, as I have already told you, is applicable only on right angle triangle, that too when we are dealing with the sides of the right angle triangle. Okay, let's do a few sums and it will be easier for you. Okay, so the first question we have here is from exercise 17b, question number 1, question number 3.1. So question number, before that, before a few questions, it was just about which are the sides of the triangles and all. So I haven't done that. I guess you can easily do that, isn't it? Those are some simple basic questions, like which is the hypotenuse and all. I have already told you the hypotenuse will be the side opposite to where an angle is formed, and it is always the longest side of the triangle. Okay, now in this one, see, one of the sides is given as 4, one of the sides is given as 7. Now I know what are the names of these sides as well, isn't it? Now this side is given as x. We needed to find the value of x. That means our hypotenuse is missing out here. See, isn't it? And we have our perpendicular, we got our base as well. So now simple, according to Pythagoras theorem, and this one you have to write. Okay, every time you use the formula. So according to Pythagoras theorem, hypotenuse square equals to base square plus perpendicular square, isn't it? So hypotenuse was x, so I have substituted, see, x square equals to base was 7, so 7 square plus perpendicular was 4, so 4 square. 7 square, 7 into 7 is 49, plus 4 square, 4 into 4 is 16, isn't it? 49 plus 16, it's 65. Now this one, from here to here, this line, I guess this is this one step will be the you'll be viewing the steps for the first time, isn't it? Now see, try and understand this one. Okay, what we are needed to calculate is what we needed to find out is we needed to find out the value for x. But what we have instead till here is we have x square. We don't have x, we have x square, isn't it? So in order to calculate x from x square, what happens is, if you remove square from one of the sides, listen carefully, if you remove square from one of the sides, you need to place square root on the other side. Okay, if you remove square from one of the sides, I'm repeating myself, see, if you remove square from one of the sides, remember, equals to divides the equation into two halves, isn't it? Till here we got monomial on both the sides, left hand side, right hand side. So if you remove square from one of the sides, you have to place square root on the other side. That's what I've done here. See, remove the square, place the square root on the other side. So square root of 65. We have done square roots on previously. We have done square root as well, isn't it? So square root of 65. Since 65 cannot be further, we cannot take the prime factors and take out the terms outside the square root. So it will remain as it is. See, square root of 65. Okay. So that is why I've written square root of 65 units. Since the units were not given, so simple, square root of 65 units. Okay. Now the second one, what we have in question number 2 here is, see, again the same triangle was given, but the triangle was a bit like flipped, isn't it? Now what you can do is, if let's see, because whatever the triangle, no matter how the triangle is drawn, if it is dealing with the sides and this symbol is there, this symbol is for 90 degree. I've already told you, isn't it? This symbol is there, then at that time the triangle is known as your right angle triangle, and we are dealing with the sides. You know that it will be the Pythagoras Theorem will be applicable, isn't it? And if you are confused with the sides, what you can do is you can simply change the figure to your usual, that is used to form. Okay, this one was our used to form, isn't it? Used to figure. Okay, so simple, what you can do is, how you can do that is simple draw the right angle triangle, which is easier for you to know the side. Now as I've already told you, the side opposite to 90 degrees hypotenuse. So from the original figure, just see, side opposite to 90 degrees hypotenuse, and hypotenuse was given as A. So that is what I've done here. See, side opposite to 90 degree hypotenuse. Now for these two sides, see, one of the sides was 5, so 5, 5. See, 5, 5. Okay, now what do we have? Got hypotenuse missing. I got perpendicular here. I got base in here, isn't it? Now what you can do, simply according to Pythagoras theorem, we can write hypotenuse square equals to base square plus perpendicular square. Pythagoras theorem, isn't it? Hypotenuse was A, so A square equals to 5 square plus 5 square, that is 25. 5 square is 25 plus 5 square 25, 25 plus 50, isn't it? See, A square equals to 50, so we need to get rid of the square as well, isn't it? We need to get rid of square as well. So A equals to square root of 50. Now I've taken the prime factors of 50. See, 2 into 5 into 5. So square root, you know, we have done this on the topic squares and square roots as well. So from two similar roots, 5 and 5, one of the roots comes out because it's a square root, so 5 comes out. It doesn't have any pair, root 2, so 5 root 2 is your answer. 5 root 2 units. See, root 2 remains inside the root, so 5 root 2 is your answer. Okay. So now moving on to the next one. So again, see, your figure is given in, again the triangle is tilted, isn't it? Now see, for those, this step is not mandatory. Okay, I'm just telling you, for those who couldn't figure out the sides or the sides, what are the actual names of the actual sides from the given figure, what you can do is you can simply change the figure to your usual easier form, isn't it? Like in your used to form, your used to figure is this one, isn't it? Here you can easily recognize which one is hypotenuse, which one is perpendicular, which one is base, isn't it? Now from this figure, what you can do is, as I've already told you, you can convert the figure, isn't it? So that's what I've done here. See again, just I've tilted the figure, isn't it? Now what do I know? 90 degree opposite. This is very important. Okay, the side opposite to 90 degree is 13. Now see, first of all, place the side opposite to 90 degree. Okay, and 7 and P. Simple, say 7P, 7 and P. Okay, the 7 and P you can keep it wherever you want. Okay, the hypotenuse is the most important side. Okay, because that is the longest side of the triangle. If you misplace hypotenuse, that is instead of 13 in here, if you write 13 in here, everything will went wrong. Okay, the most important side is hypotenuse. Okay, the other two you can use alternative. That is, I have used perpendiculars 7 here and base as P, isn't it? What you could have done is you could have used base as P as perpendicular and 7 as base. You could have got the same result. Okay, that's what I'm trying to tell you. Okay, now you know the steps, isn't it? So again, according to Pythagoras theorem, so what do we know according to Pythagoras theorem? That is, hypotenuse square equals to base square plus perpendicular square. Now hypotenuse is given as 13, isn't it? Hypotenuse was given as 13, so 13 square equals to perpendicular square. Base is given as P, so P square plus perpendicular as 7, so 7 square. So you know the steps, isn't it? So 13 square, P square. Now 7 square goes to the other side. I'm taking constant to one of the sides, isn't it? 7 square goes to the other side, becomes minus. So say P square, 13 square, 13 into 13 is 169. Minus 7 square is 49. 7 into 7 is 49. 169 minus 49 is 120. P square, I've removed square. I've already told you, once you remove the square, you need to place square root to the other side. So square root of 120. Now I've taken prime factors for 120. 2 into 2 into 2 into 3 into 5 I got, isn't it? Now from this 2 I can take out 2 of the square root, isn't it? So I can take one of the 2's out of the square root. So that's what I've done here, 2. Now what's left inside? See, 2, 3 and 5, because they didn't have any pair, isn't it? So 2 5 times 10, 10 times 30, so 2 root over 30 units is your answer. See? Okay? Okay, now moving on to the next one. Again, question number 4. See, question number 4 also, again the figure is tilted, isn't it? So again, the most important thing that you needed to know, the side opposite to 90 degrees, your hypotenuse. So I have drawn a regular figure first. So the side opposite to 90 degree was B in the original figure, that is hypotenuse was missing, so B in here. Okay, now 2 sides I told you I can take alternatively. So I have taken 15 as perpendicular, 8 as base. Okay, we need to find the hypotenuse. So again, according to Pythagoras theorem, hypotenuse square equals to base square plus perpendicular square. Hypotenuse we have as B, so B square equals to 8 square plus 15 square. Base is 8, perpendicular is 15. So 8 square is 64. 8 times is 64 plus 15. 15 times is 25. 25. See, 64 plus 225, 29. I have removed square. See, B square. As soon as I removed square root to the other side. I've been repeatedly telling you this, isn't it? Square root of 289. So take the prime factors of 289. 17 into 17. Okay, 17 is 289. So one of the 17 comes out. So B equals to 17 units. See, that is how you get your answer. Okay. Okay, a few more sums. Okay. Okay, and in question number 3. Yeah, question number 3. Say the figure was directly given. The hypotenuse was given as 29. The perpendicular was given as 21. The base was missing, and it was given in terms of D, isn't it? So no need to change any figure because it's already in our usual form, that easy form, isn't it? So according to Pythagoras theorem, hypotenuse square equals to base square plus perpendicular square. You know what to do, isn't it? Substitute the hypotenuse 29 square equals to C base D square plus perpendicular is 21, so 21 square. Now 21 taken to the other side, minus, so minus 21, so 289 square is 841 minus 21 square is 21, 21 is 441. Subtract this, you will get 400. D square is 400, so D equals to square root of 400, and square root of 400 means 20. Okay, this one I have jumped it here because I know 400 is perfect square of 20. If you know it's a perfect square, then you could directly write it this way as well. Okay, or else if you don't know, then what you can do is simply take the prime factors and then take out your answer. You will get the same answer. Okay. Okay, now the last sum for today. Here we have is from question number 6. We have here, we got 2 triangles, right angle triangles. See, a big triangle first of all, ABC, a big triangle BC, is be divided into 2 right angle triangles. See, 2 right angle triangles, isn't it? Now what do we need to calculate is we needed to find BD and BC. Okay, BD means this one. That is we needed to find perpendicular as well as BC, one of the hypotenuse to one of the triangles, isn't it? So first of all, for this, let's take this triangle. Why? Because see, two sides were already given. See, we need to calculate BD, isn't it? And BD is common side for both the triangles, isn't it? So after we calculate BD, it will be easier for us to calculate BC if we take this triangle, isn't it? So that is why I have taken the first triangle first, in triangle ADB. See, ADB. Okay. So according to Pythagoras theorem, what we know, hypotenuse square equals to b square plus perpendicular. Hypotenuse I have already told you, side opposite to 90 degree, isn't it? So for this triangle, side opposite 90 degree is this, that is AB, and gives the value is given as 10. So hypotenuse square equals 10 square equals to C. Base is given as 6. So 6 square plus BD square. That's what we are after, isn't it? But we are not after BD square. Remember, we are after BD. Okay, and you know, when you remove square, you need to place square root to the other side. That's what you know, isn't it? So 10 square equals to 6 square plus BD. 10 square is 100, 6 square is 36. We know that, isn't it? But instead, for the first, what I have done is I have sorted out the like terms. Okay, the constant terms on one of the sides, variable on one of the sides. So 6 square to the other side minus 6 square. So BD square equals 100 square minus 6 square. 100 square is 100 minus 6 square is 36. 100 minus 36 is 64. So BD square is 64. BD equals to square root of 64. That is BD equals to 8 units. Okay, that is how we solve the first step of the equation, isn't it? BD equals to 64. Okay. Okay. Now the second one, for second one we have here is in triangle BDC. Now see, now once we got the value for BD, that is this side, we got this side as 8 units, isn't it? 8 units. Now the second question, part of the question was we need to calculate BC, isn't it? As I've already told you before. Now first, if you take this triangle, for this triangle, this is your perpendicular, this is your base, this is your hypotenuse, isn't it? For BDC, isn't it? So that is what I have done here. See, in triangle BDC, according to Pythagoras theorem, see, look at the figure as well. Hypotenuse square equals to b square plus perpendicular square. Hypotenuse we have there as BC, so BC square equals to base we got 15, so 15 square plus perpendicular we got as 8, so 8 square. Now BC square equals 15 square 225, 225 plus 8 square is 64. Added this to get 289. BC square equals to 89. BC equals to square root of 289. 289 is perfect square of 17, or those who don't know that, you have to go through the prime factor method. In prime factor method you will get 17 into 17 as 289, and you got BC as 17 units. Okay, so this is how it is done. Okay, I hope you kids understood this one, and remember this one is a very important topic. Okay, Pythagoras theorem is very important because the same will be continued in class 9 as well as 10 and so on. Okay, so please try to understand this sum. If you have any problems, do let me know. Okay, so till then, stay tuned in for more updates and videos. Okay, till then, stay safe, take care, bye bye.